Hi everyone, so in this video I'm going to talk about idle ignition timing, which is a question that's come up recently a few times in the Guild of Air Fire Tuners. And the question which Old Mate has asked is, how do you set idle ignition timing? How do you know what it should be? Now, what I'm going to try and do in these videos is actually go to the actual cause of the problem rather than just the question that's being asked. So if Old Mate's asking, how do you set idle ignition timing? Then there are two possibilities. Either he doesn't understand the effects of ignition timing, or he doesn't understand why the idle condition is special. So I better explain both of those. Now, I'm not going to draw a full PV diagram and explain how ignition timing changes torque. Ignition timing also affects other things like EGTs and emissions and that sort of thing, but torque is the most important one. Now, if you've ever done this graph, and you can see in some of the High Performance Academy videos, they do these graphs. If you measure the torque as a function of ignition advance, then you'll find that there's some peak here, which actually is the ignition time that gives you the maximum torque. And around that point, it doesn't really change that much. But as you retard the ignition timing from there, the torque reduces a lot. I don't know if it goes down to zero, but you get the idea. That's the basic shape of the curve. Now, when you advance ignition past that point, the torque does drop off as well. Now, it doesn't seem to drop off at the same rate. I'll leave it to your imagination as to why that might be. But that's basically the shape of the curve. So what one person suggested you can do is set up a vacuum gauge and change the ignition timing until you read the most vacuum at constant RPM. Now that will get you to the peak, the point of maximum torque. Hopefully he meant figuratively, like watch the vacuum reading on the laptop screen rather than actually use a separate gauge, because you've got that information. So if you have a constant RPM and a constant air-fuel ratio, that is, your ECU is doing closed-loop idle control and it's closing down the idle valve to keep the RPM constant as you advance the ignition timing, then when you get to the point of maximum torque, you're going to have the least amount of manifold pressure, that is, the most vacuum at that point. So that's how you can find that point at idle. Obviously you can't do this on a dyno because in the idle condition the net power output of the engine is zero, right? Because it's not driving any load and the output must be zero if it's a constant speed. So that's one way to do that. The other way you can do it is if you have a constant amount of air going into the engine, that is you're running open loop idle control or no idle control, then the maximum torque condition will occur at the maximum RPM point. So if you keep advancing the ignition timing, the RPM is going to keep increasing, and beyond that point you can keep advancing it and it's not going to increase it very much. Now this point's actually surprisingly high. I discovered this, I can't remember how many years ago now, on my MX-5 with the 1.8 litre engine. At idle, the maximum torque occurred at about 45 degrees or something like that. I was kind of a bit worried about putting it in, but it wanted it, and it just kept getting smoother, and the idle kept getting faster, and if you've got enough high enough octane fuel, you can stab the throttle off idle and it just zings and takes off, and it's wonderful. So there must be a reason why people don't run 45 degrees of ignition timing at idle, why OEMs don't do it, and why aftermarket tuners don't do it as well. So why don't we just run idle at the torque peak? And the answer is because you need some torque in reserve. For two reasons. First of all, if the ECU is going to try to do idle control with ignition timing, that needs to be in this part of the curve, so that a change in the ignition timing actually makes a change in the torque. If you're at this part of the curve, then the ECU can make a change to the ignition timing, but it doesn't reduce the torque very much. And what's worse, if you try and increase the ignition timing, you lose torque again. So the only way that the ECU can control the ignition timing then is with the control the idle speed, is with the idle valve, and that's very slow to respond compared to ignition timing. With the idle control valve, by the time you change its position and the air gets into the plenum and all the pressures equilibrate and so on, we're talking several hundred milliseconds for that to happen. With ignition timing, when you make a change to the ignition timing, the torque actually changes on the very next spark event, which even on a 4-cylinder at 600 RPM is only 50 milliseconds, and if it's a 6-cylinder at 900 RPM, it's, I don't know, 20 milliseconds or something. So it's much faster to do closed loop ignition timing, closed loop idle control with ignition timing as well. So that's one reason to do it. Another reason is that you need to have some torque in reserve to actually make the idle stable. If you set your idle so that you've got so little air going into the engine so that it's idling at the right RPM with ignition timing this high, then it means that it's going to be a lot harder to get the return to idle condition nice. You'll find it'll be a lot easier to get the engine to stall when it's coming back down to idle. It's also going to be less stable when you turn things on, like electrical loads and things like that. Or air conditioning, power steering, pumps, things like that put a load on the engine. So that's another reason why we deliberately detune the idle condition. Now there's one more thing that I'll say. So normally, from factory they run about 15 degrees or so. I've seen 10 degrees on some engines. I've seen 20 degrees on some engines from in factory workshop manuals. Actually, I saw one which was 6 degrees. According to the workshop manual, which surprised me a lot. But let's just say that you set it for 15 degrees for the sake of argument. Now, if you've got a highly modified engine with large injectors on it, and you put large injectors on it because you want to be able to run ethanol, but this is a flex fuel thing, so it's on petrol as well. You might find that, especially if it's a fairly standard engine internally, that it needs so little air at idle that you actually have trouble delivering the correct amount of fuel for that with those big injectors. So if you've ever looked at the amount of fuel that gets injected versus the injector pulse width or duration in milliseconds, and that's in microliters, then you'll see that for the first amount of the fuel injection time, the injector doesn't actually open. It'll say from 0 up to, say, 1 millisecond or something like that. Now, then when the injector turns on, often there's a bit of a step, and then after that it's hopefully a fairly straight line. Now, the gradient of that line is the flow rate of the injector, but what it means is that being able to deliver any amount of fuel in that region there is very difficult or impossible to do it accurately. And this is why you can have injectors that are too big for a certain engine. But one trick that you can do if you're marginal is you can reduce your idle ignition timing to, say, 10 degrees or 5 degrees, 5 degrees or something like that. And that means that the engine produces less torque with the same amount of air, which means that to actually get it to the same idle speed, you need to have more air going into the engine, because you detuned it. And more air going into the engine with the same air-fuel ratio means that you need more fuel. So if you were previously in that sort of region, and you can get up to, say, that sort of region there, then suddenly you can get mixtures which are somewhat stable again. So that's a bit of a trick. I don't like it that much because it makes the engine sound very flat. Obviously it increases your fuel consumption, but it's one trick that you can use. So I hope that helps with understanding idle ignition timing. Thank you.